All right. I actually cannot believe I'm even saying this, but we have finally reached the last brand new lesson of the year in Algebra 2. Absolutely crazy. Wish we were doing it together in class, but we'll take what we can get. So we're going to be doing one more day of drawing conclusions from data, and today what we're going to be discussing is what we call the difference in means. Now generally this is something that they would use when you're analyzing an experiment to see if a treatment is really more effective than, non-treatment, or one treatment is more effective than the other. And so what you would do is you would look at like the average or the mean of each group, and you would see it, do those means actually come out to be pretty similar to each other or totally different? The reality is when you break people up into separate groups or things into separate groups, they're naturally going to be a little bit different just because that's the way that it works. So you have to see, is the difference between the group that got the treatment and the one that didn't get the treatment really very different where it becomes statistically significant? Or is it just because of the way that those two groups were actually broken apart, that's why you have a slight difference between the means? Now, there's a technical way we're supposed to do this in terms of statistics. So if you go to a higher level stats class, you'll basically analyze statistical significance if there is a low probability of obtaining that difference by chance. Now, I find that sometimes that terminology gets a little overwhelming. So what I'm going to do here is I'm going to try and tie this in with the normal interval that we've been talking about for the past couple of days. Because if you take a look at the distribution of differences, like you can see in this question, okay, so basically they took the difference between these groups and they ran a simulation to get what all the differences could possibly be. You see that it's basically something like a symmetric distribution. It's not perfect. So what I'm going to do is I'm going to treat this as if it's like a symmetric, aka a normal distribution. I'm going to calculate what I think is the standard deviation. Again, when it comes to distributions, you can approximate the standard deviation by doing the range divided by 6. So in this question, it looks like our highest value is 1.4. Our lowest value, negative 1.6. And if I divide that by 6, that comes out to give me a standard deviation of something like 0.5. Again, this isn't a perfect system, but you can kind of get a pretty good idea of things that are relevant or not relevant. I'm going to use that the mean is 0, even though I know probably the mean should be more like right here at that 0.2, because that's kind of like that highest value. Just to simplify, I'm going to basically use that the mean is 0. So pretend like that's the middle of my distribution, and then do 2 standard deviations out in each direction. Okay, so 2 standard deviations out to the right. 2 standard deviations would be 1 whole unit because I'm doing twice 0.5, right? So if I go out 1 unit to the right, basically here is where my normal interval will stop. I mean, I guess technically it shouldn't even include the 1 as we had just said yesterday, but this is just an approximation. And then I'm going to go 1 unit out to the left, so just about here. So any sort of difference that falls between these two lines inside that normal interval is what we would refer to as a normal difference in means, which is a result of just two groups being just broken up into 2 different groups. It's not a result of the treatment. An abnormal result, okay, would be something that's outside of that normal interval, and an abnormal result would mean a treatment caused that. Okay, a treatment was more effective or less effective depending on what's going on in your problems. Okay, so if you go down to letter B, again, I'm going to skip the part about A because I'm just trying to connect it to stuff you just did before. Would a difference value of negative 0.6 be considered statistically significant difference? Okay, abnormal is what we mean by statistically significant. Okay, was that treatment really effective? That only happens if you get an abnormal result. A normal result means that it's a result of just happening by chance, the way the groups were just randomly broken up. So the fact that negative 0.6, let me just change colors for a second, negative 0.6 falls over here within the normal interval. Okay, so since a difference of negative 0.6 is in the normal interval, it is not statistically significant. Okay, Okay, so therefore, if this was some sort of medicine or something you were testing out, you can't claim that that medicine was actually really that effective in terms of whatever it was trying to do, because of the fact that that difference in means fell within a normal range. Okay, it has to fall in the abnormal range to be considered statistically significant. So look at the next one, letter D. Would a difference value of negative 1.4 be considered statistically significant? And again, when you see that word, think abnormal. Okay, so when you take a look, we're looking at negative 1.4. Negative 1.4 is definitely falling in the abnormal range, so therefore it is statistically significant. Okay, so since the difference of negative 1.4 falls outside the normal interval, okay, it is considered statistically significant. I swear I can spell. Okay, and that means that if you were doing some sort of testing of treatments and the difference between your control group, the group that didn't get the treatment, and the other group that did get the treatment, experimental group, whatever you want to call it, if the difference between those two groups is abnormal, it means that that treatment had some sort of an effect. Okay, so once again, kind of try the same idea. So if you take a look at the next problem, it says a claim is made that listening to music during exams relaxes students and therefore they will perform better on these exams. 100 students are randomly divided into 2 equally sized groups for an entire school year. Each member of the first group takes their test while listening to music, while each member of the second group takes their test in a quiet setting. And then since students are in both groups are given the same test throughout the year. Okay, so what we're going to do, it says calculate the mean difference in the final grades, Group A minus Group B. Okay, so the means of Group A and Group B are right here. The standard deviation is not going to have any impact on this problem. Just focus on the means. Okay, so the mean difference, and specifically they wanted you to do it as Group A minus Group B. So X bar of A minus X bar of B comes out to be 82.25 minus 84.12. Okay, so that comes out to be a difference of negative 1.87. So what does that actually mean? It means Group A scored on average, and again, this is an average because you're talking about many people grouped into one statistic, 1.87 points lower than Group B. So when you look at that, you must go, oh, okay, well, clearly Group A was impacted by either listening or not listening to the music because they scored almost 2 points lower. But the idea is maybe that 2 points is just based on the way the two groups were made. Maybe it doesn't have to do anything with the music. So what happens is there's a simulation that was run where the student grades were re-randomized, meaning they were just put into different groups and different groups and different groups and different groups, and eventually the mean differences were calculated to give you a distribution. And as I said before, you can see how it kind of looks like a symmetric distribution. Let's say that the mean, like the middle of our data set, is basically at 0. If you had to approximate the standard deviation, again, you would do range divided by 6. And again, this is more of an approximation than the true method, but you can still draw your conclusions very well from this. So it looks like our highest value is around 4.5, and my lowest value is around negative 4.5. And if I do 9 divided by 6, 1 second, 9 divided by 6 comes out to be about 1.5. Okay, so that's my standard deviation. So remember, if you go from your middle of your data set, 2 standard deviations in each direction, you can make that normal interval. So 2 standard deviations would be 2 times 1.5, or 3 units from the middle of my data set. So if I go out to 3 in each direction, everything between those 2 blue lines is what I would consider a normal difference in means, which means it was a result of just the way the 2 groups are broken up. It had nothing to do with the treatments. Anything outside of that would be considered to be abnormal. And that means that whatever treatment you're working with would have an impact. So the question is there a significant difference in the final grades? Is it statistically significant based on what you saw? Well, you take a look at that negative 1.87 and see where does that fall in this whole diagram. If you look, negative 1.87 falls somewhere around here. definitely within the normal range, and because it's within the normal range, it means it's probably just based on the way the two groups were broken up. It has nothing to do with the actual music, or you don't have enough data to prove that it's a result of the music. So you would say, since the difference, again, I swear I can spell, of negative 1.87 falls in the normal interval, it is not statistically significant. Okay? And therefore, what you're saying is that it's unlikely that listening to music actually had any, result on the student test performance. Okay, so let's do one more example. We took a look at example number 3. So in this case, you actually have to calculate the mean first. It says, imagine 10 tomatoes of varying shapes and size are placed in front of you. So you have 10 random tomatoes. You break these two groups of you break these tomatoes into 2 random groups, and you test to see if there's one nutrient that provides, a more effect that creates larger tomatoes than another. Okay, so the idea is you're breaking these 10 tomatoes up into totally different random groups. And again, you want it to be random, so you're not having some sort of an impact on the outcome. So if you remember to do an average, you would add up all your values and divide by how many you have. So in the first group, you would end up getting an average of 7.84. In the second group, when you add them all up, divide by how many you have. The mean in the second group comes out to be 5.4. So now you want to calculate the difference in those means of group A minus group B. So group A, the mean of group A minus the mean of group B comes out to be 7.84 minus 5.4, which is 2.44. Okay, so what that actually means is that group A's tomatoes grew to be 2.44, doesn't look like they give you units. So let's just say ounces for right now. 2.44 ounces bigger on average than group B. Okay, so you might say, okay, 2.44 ounces, that seems like a lot, right? Whatever treatment group A had was definitely, important. Well, we don't really know that until we run a simulation where you re-randomize the different tomato weights over and over and see are the differences between those groups. So basically you take your 10 tomatoes and you keep switching if they're group A or group B and look at the difference in means between those two groups. Okay, so again, what we're going to do right now is we're going to skip the part about probability, and you're going to use the idea of a normal interval to see if this is actually a significant difference. So the middle of our data set, again, we'll look at it as 0. Standard deviation is approximated by doing range divided by 6, because this is an approximately symmetric distribution. So our range looks like our highest value is 5, our lowest value is negative 5 divided by 6, and 10 divided by 6... 10 divided by 6 comes out to be about 1.7. Okay, so if I double that, comes out to be 3.4. So if I go out 3.4 units in each direction, that makes the normal interval. So if I go to the right 3.4 units, it's about here. If I go to the left 3.4 units, it's about here. Everything that falls within this range is considered a normal difference in means, just solely a result of the way the two groups are broken up. Anything outside of that would be considered abnormal, and abnormal is what we consider to be statistically significant. So let's take a look at where 2.44 falls. 2.44 definitely falls within the normal range. So you would say, since the difference of 2.44 falls in the normal range, okay, it is not statistically significant. Okay, therefore, we cannot conclude the treatment had an impact. Okay, so that's the idea. Statistically significant means an abnormal result, and an abnormal result means your treatment was effective, okay? If it's a normal difference in means, it means that difference was solely created by the random grouping of those two groups, Okay, miss you guys. Hope you